This is a typical AC motor. Its external parts include a frame, a shroud, and an end bell. The frame houses the stator and the rotor, and it also provides a means to mount the motor to a foundation. This motor is designed to be mounted horizontally, but not all motors are mounted horizontally. In some situations, motors are mounted vertically to drive vertically mounted shafts. For example, these vertically mounted motors drive sump pumps. Motors can also have a variety of frame designs. Open frame motors are commonly used in non-hazardous areas. But some process applications require motors to be completely enclosed. Electrical equipment can cause explosions in areas where there are flammable liquids, gases, or dust. In these areas, totally enclosed, explosion-proof motors are generally used. During normal operation, an AC motor produces heat as a result of current flowing through it. Many motors use fans and ventilation openings to get rid of heat. On this particular motor, the shroud has openings to admit air into the motor to cool it. A fan cools the motor by pulling in air through ventilation openings in the shroud. As air is blown across the motor frame, the air carries away heat produced by the motor. Smaller motors may be cooled by simply letting heat escape from the motor frame. Other designs are also used to remove heat. For example, this motor has a set of fins. The current rating is the amount of current the motor can draw during normal operation without being damaged. The amount of current a motor actually draws usually varies over a range. The amount of current drawn at any one time depends on the load on the motor. In other words, how hard the motor is working. Horsepower is a rating of how much mechanical power the motor can be expected to produce. The operating speed rating refers to how fast the rotor is designed to rotate during normal operation. Most of the information on a motor's nameplate can be used to determine what a motor's normal operating conditions are. This information is important when a motor is selected for a given application, and it may also be important to maintenance personnel. Let's continue now by looking at some of the internal parts of a typical AC motor. This is a stator from an AC motor. The end bells and the rotor have been removed to see the stator better. The stator contains several coils of wire called stator windings that surround the rotor. Current flow through the stator windings produces magnetic fields. The windings have been dipped in an insulating varnish and then baked. The fins provide additional surface area to dissipate heat into the surrounding air. Another important part of a typical AC motor are the end bells. The end bells house the bearings that support the motor's shaft. Bearings provide support for the rotor shaft and allow the rotor to turn. For proper operation, bearings must be kept lubricated. Lubrication reduces friction between the bearings parts. There are some motors that use sealed bearings that do not have to be relubricated for the life of the motor. The bearings of some other motors are greased through grease fittings as part of a regular maintenance schedule. Other motors use a constant level oiler. A constant level oiler holds a small supply of oil that drains by gravity into the bearing. The design of the constant level oiler allows the operator to look at the level in the reservoir and add more oil when necessary. A connection box on this motor protects the motor's wires or leads from damage. These wires electrically connect the motor to a source of AC power. All motors are designed to operate according to certain specifications. Many of these specifications are listed on the motor's nameplate. For example, this nameplate includes information about voltage in volts, current in full load amps or FLA, horsepower designated as HP, and operating speed in revolutions per minute or RPM. The varnish insulates the windings from each other and prevents short circuits or grounds that could damage the windings. The rotor is mounted on a shaft. This rotor is made of conducting bars that are shorted together by end rings. The rotor bars with their end rings are attached to a shaft so that the whole assembly can turn together. As the magnetic fields generated by the stator windings pass through the rotor, a voltage is induced in the rotor. The voltage creates current flow through the rotor, which creates another magnetic field. The interaction of the magnetic fields generated by the rotor and the stator windings produces motor action, which causes the rotor to turn.